It's nowhere near as that nice. Okay.
Gosh, such a klutz.
I think you need batteries.
Awesome. I have.
So, gallon of wastewater, and comes out a little gray actually. It's 99.9% clean water. Less than 1/10 of a percent is actually anything that we need to worry about. Biggest chunk of it is suspended solids. They can be organic, inorganic. There's another large percentage that's dissolved. It's in there, it's a contaminant, but it looks like part of the water now. And there's a small percentage that's actually toxins, things like mercury that have been released that we need to worry about. Standard sewer system, water comes from the residences, comes from institutions like this, comes from industries. It all comes in the same sewer. It also, we have a combined sewer system. They used to be very common throughout this state. They were great technology for its time. If rainwater would come in, fill up the catch basins, all go into the sewer system. As long as it's not a real heavy rain, it all goes into the plant. Problem is, when a really heavy rain, some of it ends up going straight into the river. Not nearly as gross as what you think it is, because at that point it's 90% rainwater. But still, in 2002, the state issued an unfunded mandate. We have to eliminate those. Unfortunately, they also didn't give us the money to do that. We're ahead of the game here. Okay, maybe I just need to outsmart the remote.
So where is this button 7? The button just below button 7.
This is how they work. Normally the sewer runs at about 40–50% full. It's set at a slants, so all the wastewater moves at a minimum speed of a foot per second. So it keeps everything in suspension, nothing just sits in there. If it does sit in there, then I was pushing that one. I need to aim it at that, not at that.
Yeah, that.
It is a matter of me outsmarting.
It's okay.
However, when we get rain, we get it, fills up the catch basin, goes in. If we get too much, it goes over the CSO wall and goes out into the river. So we're in the process of breaking those up. The problem is, if the sewer gets too full and there's no place for the water to go, it goes into people's basements. New construction now requires a plug valve, so that's much less likely to happen as long as people maintain their home. These signs, it shows where all of our sewer overflows are. And pipes like that, nothing unusual. If we've got a lot of rain, if we've got a lot of snow melt, and you see water coming out, it's doing what it's supposed to do.
So those signs let you know that it's an overflow pipe. What they're trying to do is eliminate that so the overflow doesn't go into the river and that it goes into the storage tanks.
That's right. So we're in the process. We've got our consent decree. We have to eliminate them by 2025. We're actually about 5 years ahead right now from where we need to be. We've installed 1 million gallon storage tank at one of the lift stations. We've got 2 or 3 more to help us do that. We'll collect it under high flow, store it there, and then release it slowly. The plant was built in '52. We've had 3 upgrades since then. We're in the process of having another one right now. We're in the planning for it. We have 250 miles of combined sewer system. Our average flow is around 15 million gallons, but in high flow, it'll go beyond our design capacity of 44. I've actually seen around 60 rolling in under a big rain. These are the steps that we'll be talking about. Preliminary treatments, where we remove the inorganic solids. Primary treatments, where we eliminate most of the organic solids. Secondary, where we take the excess of nutrients out of the water. Tertiary, where we remove where we disinfect the effluent so that there isn't any bacteria left in it. And then we've got a couple of steps of solids treatment because we make extra organic solids in the process.
Give me 1 second.
Sure.
What I did was I did preliminary inorganic, primary organic, secondary nutrient, tertiary disinfectant, and 2 solid steps. And I have my notes. I'll rewrite them nice and neat if you want to see them again if you missed anything.
What time should I time this for?
Well, that gets out at 10:05.
Okay.
So you can plug in.
Okay. So this is the first step, preliminary treatment. Water comes in, it gets caught by a bar screen, big solids like pop bottles, that sort of thing, get caught up in that, and this is our Headworks building where that is. It comes in through 2 places, all goes through there. These are our bar screens.
Can you hit one of the light tasers?
These are set so that when the bar screens get too filled, the rates automatically come down. There's floats in there and it's also on a timer. I really liked that when I came to Elkhart because I came from a smaller plant where it was me with a rake doing it by hand every 2 hours. This was just heaven.
Did you find anything strange or weird when you did that?
A couple of things. The worst thing that I ever found, the most shocking thing, turned out to be a baby possum, but it had lost its tail and its fur, so when I looked at it from a distance, I didn't think it was a baby possum. I just thought it was a baby, and that freaked me out for a while. One of my operators has found a $50 bill that he bleached out, took his wife out for dinner. That's the best find that we've got so far. One of the guys that works there has a rubber ball collection, and so if it gets flushed, it ends up with us sooner or later.
How many fish have you found?
A couple. The combined sewer overflows when the river is really flooded. It'll be above those. So I've had occasions where I had multiple weeks where we had river water coming, backfilling into the plant. And I was at maximum flow, even though the water really didn't need to be treated. Yes, sir.
Have you ever found car keys?
Never found car keys. Probably just missed them in the system. Why, did you lose a set?
No, I flushed keys.
Yeah. All the water that goes through the bar screens, it goes into 2 tanks like this. Like I say, we keep the water moving at a foot per second, keep everything moving. Here we start using load technology. We let gravity do most of our work for us. We slow it down, let things settle down to the bottom. The heavy inorganics settle out. There's a sweep arm that pushes it into a hopper where we pump it off, send it to a landfill, a sanitary landfill. This is mostly things like sand, silt, eggshells, that sort of thing. Coins, corn. People eat a lot of corn. From there, it goes through the primary treatment where we take all the flow from those 2 tanks and we split it up among 10 tanks. Slow it down. That lets the heavy organics settle down to the bottom, becomes sludge. The stuff that's lighter than water floats to the top, and it's called scum. There's actually, it's not just a generic term. We have got sweep arms that move continuously. It pushes the scum to one end where we pump it off. Again, it gets sent to the same landfill as the bar screenings and the grit. The sludge gets pushed to the other end. There's a hopper there where we pump it off to where we treat the solids. And the water moves on to secondary treatment. Settleable solids are mostly organic. There is still some inorganics that get past the grit tanks.
Is that what it means by inert?
Dirt, yeah,
Okay.
that sort of thing. These are our primary tanks. constantly moving. We haven't gotten awards, safety award, only because I don't have covers on those chains. Everything's made out of plastic in there. It's really reduced cost, and it makes for an easy repair. Secondary treatment, we've got 5 tanks. Everything goes through. We keep bacteria alive in there. It eats the bad bacteria that comes in. So when you add oxygen to it, you get carbon dioxide and water, as well as some byproducts.
Make sure that you write this equation down. So he has the inorganic matter that he's putting into the chamber. They're going to pump oxygen into it with the bacteria so that they create the water, the carbon dioxide, new cells, and the byproducts.
Because we do always add air to it, it reduces the specific gravity. It makes the water much less dense. So it's impossible to swim in there. It makes it the most dangerous place that I've got in the plant. One of my operators, one time on 3rd shift, had his son with him. I found about this after the fact. And he was messing with him, walking along there. He kept shifting his weight into him, almost knocked him into the tank. I'll tell you. Okay, it is a good story. And he practically fainted when I told him how close he was to killing his own kid. We used to run a process where we didn't have air running in a few of them to biologically remove phosphorus. We are not using it at this time. And so the ducks, the waterfowl, would land in there. And I always wondered whether they would sink in the aeration. I know a human can't, but whether they would. And one landed in there, and I snuck out there and slowly opened up the air, and he slowly got up to about there, no clue, and then I turned the air off, and he popped right out, and then I played with him a little bit. He kept going up and down, and finally scared him off. Doing this also helps make the condition, the sludge, it helps it settle better. So the solids settle down to the bottom using low technology again. We pump the solids off. Some of it goes back as food for the bacteria that we've got there. Some of it gets sent off for later sludge handling. And the water moves on. This is the water going into the aeration tanks. Surfactants are an issue, lots of soaps. This is what the tanks look like. This was when we were running the anoxic zones. You can see we're not moving air into that first one and the third one there. This is the bacteria that we look for. It helps us decide whether the tanks are healthy or not. We're looking. Every day I have somebody get a sample and they count the bacteria that's in there. And if we've got a lot of rotifers, I know that I've got an older sludge and I need to waste more out of there. If I've got a lot of flagellates, it's on the young side and I need to slow things down. It helps keep the system working well. Yes, sir?
So how do you know what's the good bacteria and what's the bad bacteria?
Well, what's coming in is what we need to get disposed of. But we keep an eye on what we've got going in there at this time.
If you remember when we did the water treatment lab, there was a list. If you looked at the packet I had on your table, I didn't require you to, but there was a list of bacteria and little animals that lived in the water if it was considered healthy. So if it was considered healthy, you would find certain animals there, and they would also tell you how good or bad or young or old everything was. Kind of like CSI when he's looking at the bugs that are in there, it can tell you how long everything's been sitting. So some of these little guys will cause some really nasty issues if we end up digesting them, to where other ones are supposed to be there.
Yeah, right now I'm working through something. I had a local industry dump fuel oil on me. I had 3 days where I had heavy fuel oil coming in, and it killed off my nitrifying bacteria. So we're not in violation right now, but instead of less than 0.1 of ammonia leaving, I'm running about 3.5. The limit's 10.
So what that means is that there's bacteria in there that can take care of that nitrogen? Is that
Yeah,
correct?
it takes the ammonia, breaks it down into nitrites, then takes the nitrites, breaks it down into nitrites, and then it breaks that down into elemental nitrogen, which just dissipates off.
The bacteria do all of that.
Yes.
That's amazing.
And right now, not only am I not happy where my ammonia level is, but it's also got too many nitrites in there, and it's interfering with the chlorine. So I've got to feed a lot more chlorine than what I should have to. Question?
How long did that process take?
Are you talking about the solids or the water?
Solids.
The solids, it's generally takes about a week for it to get through. And some of it keeps processing all the way, keeps going back. That's just an average. One more. There we go. Water from there, from the aeration tanks, goes into our final clarifiers. We've got 8 of those, and as I showed in the graphic, it just settles down. It forms, the sludge settles down at the bottom. Clear water runs over the top. I've got 80% removal required. At this point, we're running around 99% solids removal. Normally, we're running 99.9% ammonia removal because of my problems. Right now, I'm down to around 92. Phosphorus removal, I'm running about 88% removal. We're running well above what we have to, and it's just because we're proud of what we can do. Back. Back.
Here.
One more. There we go. This is the tertiary treatments. We've already settled, gotten most of the solids out. It's still charged with bacteria though. We have to kill that. So it goes into this tank where we keep about 0.5 part per million chlorine. And every once in a while it overwhelms one of the ducts. We got to fish that out. Not nice. But that kills off the bacteria. From there, it flows into another tank where we add sulfur dioxide. And that deactivates the chlorine because we can't release chlorine into the system either. It's in a lab setting, it's a 1-to-1 ratio, but we've got a cascade aerator that we built. It's like a man-made waterfall. It reduces the cost of sulfur by about 20%. And at over $500 a ton, that's some serious savings for people. The water from there goes straight out into the river, where it's much cleaner than what the river water is.
So after the wastewater comes into the treatment plant, goes through all the stages, it then goes back out into the river, but it's cleaner than the actual river water.
Absolutely.
That's the answer to the warm-up, if you didn't catch that.
As a matter of fact, I'm also responsible for the drinking water. When we release it there, it's cleaner than what the water is when we pump it out of the ground to polish it for consumption. But we've got so much water, we don't have to do anything with it, but just let it go again.
So in this area, our drinking water comes from the groundwater.
In this area, it does. A lot of plants have got surface water plants. We don't have any. And North Main Street is on the edge of being under the influence of surface water, but so far we haven't passed that threshold yet.
Do you have to take care of Rangers drinking water? Or
No.
is that something different?
That's what different. Biosolids that are left will be pumped off. It goes into a thickening tanks, and it works just like the other tanks. Put it in there, let it sit for a while, let the solids settle down to the bottom. We pump it off the bottom to get it. Try to treat as little water as what we can. The water that runs over the top just runs back to the head of the plant. From there, we pump it into digesters. They're anaerobic, so that it's got no oxygen. Because it's got no oxygen, the digestion creates methane gas. The methane gas is used for burners because we need to keep it hot. We run a process, it's a mixed process using different temperature stages, and that helps us produce Class A biosolids. So I've got very little restrictions on what I do with it after this fact.
What does Class A biosolids actually mean?
It means that there's less than 1,000 active cultures, and it's got some very strict limits as far as the metals content.
So it's pretty clean.
It's very
biosolids.
clean. As a matter of fact, most of it gets trucked right out to farmers for fertilizer. But to do that, we've actually got 3 digesters. The first one we keep thermophilic, it's at least 125 degrees Fahrenheit. Then we run it into another one that's 100 degrees where different bacteria eats it up. Then it goes into a settling tank before it gets dewatered. Stabilized solids go into dewatering. We mix the solids with a polymer and put it through belt presses where we put hundreds of pounds per square inch and squeeze the water out of it. It goes from very watery, about a 2% solid, to like a thick clay, about 20% solids. The water that comes off the top heads back to the head of the plant. The rest of it drops into semis, where some of it still goes into the landfill. Used to be all of it did, before we started doing Class A solids.
That's the county landfill.
Another big chunk of it goes into farmers' fields.
Do
Actually,
you
most
sell
of
it
is.
or do you give it to them?
We've always given it to them in the past, and just last September we opened up the Toledo Road Organics Distribution Center, and we've set a price at it. They're used to getting it for free, and actually I've got more cost in disposing of it if I don't give it to them, so I'm not charging them at this point.
So technically, giving it to them for free saves you money from sending it to the
Absolutely
landfill.
does. I'm hoping that eventually I'll get so much demand that I can charge them and have people take it, but I'm not there yet.
You gotta play economy with it.
Absolutely. Some of it that goes out to our biosolids pad, our digesters. Our belt presses where you can see the solids coming off. And we've got 2 semis that truck it out. Usually about 2, 3, sometimes even 4 loads a day. But some of it gets mixed in with wood chips from the street department and leaves from the street department so that they don't have to landfill their stuff and save the city money that way. We compost it out, and the farmers aren't just thrilled with it then, but we sell it at the Toledo Road Distribution Center and to local gardeners. It really helps their soil out. That was actually landscaped with just straight biosolids, and it's took off amazingly well. This is why we treat the water, so that we've got nice areas like this where we can enjoy it, as opposed to things like this. The river was on fire in the Cuyahoga River in 1952. The environmental movement has done a lot for cleaning things up.
So when we were looking at the water section, we talked about Granger's water and how it's getting contaminated because of all the septic systems.
Yes.
And then we also, that was actually the week, ironically enough, that West Virginia's water was contaminated because of the spill. If that was actually here, how would we deal with that?
If it was here, we wouldn't have nearly the problems because we've got groundwater plants. Most utilities in this area are surface water, and I don't have contingency plans for it because I don't have to worry about it.
So we would be safe because we
We
get
would be
our
safe
water
here.
from below.
We would be safe here. Our North Main Street plant, the oldest water plant, was built in the 1880s. And Wellfield Gardens is where we get water now. But there used to be horn manufacturers on 2 sides of it and a dump on the 3rd side. And of course the horn manufacturers, when they were done with their solvents, they just poured them out on the ground. And so that's why we've got the air stripper, because there's volatile in the water there, and we pump it into the air stripper where it blows air up through it and strips off the chemicals.
We've talked about volatile organic compounds and air strippers before.
And we were expecting to be running that until 2030, but the water is actually starting to test out clean. So it looks like we may be able to abandon it soon. Yes, sir.
So did this happen from like all the chemicals in like one spot?
Yeah, it used to be people that were done with the chemicals, they just dump them out. People would change their oil, just dump it out on the ground.
Like on the grass at their house, and it would end up contaminating everything. So,
Industries had no regulations what they did with their stuff, and it was much easier to just dump it.
That's one of the
That's
things
right.
too, on what we flush down the toilet actually will affect the wastewater treatment plant. And remember, that water is going back into the river. So, you know, dumping medications and taking too much, what does that do to the?
That's something that is up and coming. We don't have the technology yet, but we're starting to do studies where NSAID drugs, like aspirins, ibuprofens, when you take too much of it, there's only so much that works in your system. The rest of it you eliminate. It goes in through the sewers, and we don't eliminate it. It goes into the rivers. It doesn't hardly affect us because it doesn't stay in our system. It goes into the fish's environment, though, and the fish are starting to be affected by it. They're losing some of their secondary sexual characteristics, and who knows where that's going to end up.
So by taking too much Advil or too much Tylenol, you're effectively creating biomagnification in the St. Joseph River.
Dang.
Yup.
Everybody's contributes.
Okay.
That's what's.
Anybody else have anything? Yeah, go ahead, Austin.
So the mulch and everything they use in the bio stuff, that contains human waste.
Some of it does.
Yes.
It's Class A biosolids, so we've already killed off the bacteria, and part of the process is that we have to measure the temperatures of it to get even further of the fecal kill. And yeah, it's makes great fertilizer.
Can you talk about how we want to try using UV light and that chemicals?
Oh, sure.
What that means?
Led into it last one because somebody asked about our big chlorine leak that we had that closed off the highway. It wasn't that bad, actually. I had somebody changing out a chlorine tank. We have tons of mass destruction in the plant. And she messed up a little bit on the procedure. Had a lead washer that wasn't quite in place. And opened it up, started spraying chlorine gas at her. She closed it down like she should have. But chlorine gas expands 200 times volume when it's released. And so it kept coming out of the system at her. So she went running out saying that she had broken a nut off the steel tank. Little tiny skinny lady. And totally overreacted. But the operators that weren't nearby, I've got 2 operators by radio, ready to call hazmat in case there's a problem. We've got a lot of strict safety protocols. They didn't go in to check because they're not allowed to. They heard that we had a major chlorine leak, so they called hazmat. Hazmat closed everything down before they had a chance to check it out. And by the time I got there, it was clear that it wasn't that bad. However, it is very dangerous. A lungful will kill you. And we're working on a plant expansion now because part of the CSO removal, we have to be able to handle 60 million coming into the plant. And so we're doing a big upgrade. And part of it is we'll no longer have chlorine and sulfur dioxide there. Instead, we will have ultraviolet radiation. So the worst that that could do is possibly blind somebody if they didn't follow any of the safety protocols. But whereas chlorine will kill the bacteria, one bacteria doesn't make you sick. It's when it gets in your system and reproduces. And what the ultraviolet does is it warps the DNA so that the bacteria can no longer reproduce. And I can't wait to get that system going.
If you looked at the warm-up, that's what they had in the beginning. They had either the chlorine option or the UV option. So I wanted to make sure that that was mentioned, that that's one of the goals with our wastewater treatment plant here is to go with the UV option. Does anybody have anything else? It's only when it multiplies and reproduces, and basically by doing the UV radiation on the bacteria, you're basically sterilizing them so they can't reproduce. So, it's safer for the operators, the water, and for ourselves to use the UV light rather than chlorine and sulfur dioxide.
The system I'm pushing for is supposed to automatically turn off the lights the minute it starts being pulled out of the water. And the water will absorb most of the energy, and I'm planning on putting rubber mats over the top so that they will be completely shielded.
So remember, just like in the air lesson we had, we're protected from the UV light because of our amazing atmosphere. Does anybody have any other questions?